Okay, so 7.2 deals with multiplying and dividing rational expressions. And honestly, this section is very, very similar to 7.1, which is simplifying. It's important for us to realize the connection to basic fractions, because if you understand basic fractions, then you can understand your evolution to dealing with rational expressions that have algebraic terms in them. So let's look at 2/3 times 6/8. So when we learned about multiplying fractions, you learned a couple of ways. You can just multiply it across and then reduce, or you can reduce before you actually multiply the problem. So in theory, the thought is you should actually break it down and simplify before you do the multiplication, so that way you don't have to break down larger numbers, right? So like here, 2/3, they can't break down anymore, but 6 would be a 2 times a 3. 8 would be a 2 times a 2 times a 2, or you could do 2 times 4, however you understand it. And so then you would cancel like factors, right? So we would be left with at the top, we still have a 2 and a 2. So we'd be left with at the top 1, because everybody canceled, with 2 at the bottom. So 1/2. They also teach you that you could just do 2 times 6, 12, over 3 times 8, 24, and then reduce that, right? So then reduce the 12 over the 24 if you know your factors. Otherwise, you would have to break down 12 into factors and break down 24 into factors and then cancel. I messed that up. 2 times 2 times 3, 2 times 3 times 2 times 2. So 2's cancel, 3 and 3 cancel, 2 and 2 cancel. So 1/2. Same difference, right? So when we're multiplying rational expressions or fractions that contain variable components and are like polynomials, we don't want to have to multiply and end up with some product and then have to break it down again. And so what you want to do is you want to focus on the original way, which is to break down your individual terms in your multiplication first, so that you can reduce the problem before you multiply it. It doesn't make sense to multiply the expression just so you can break it down again. So we're going to basically follow the same rules we did in the previous section. We are going to factor wherever possible. And then you're going to cancel like factors. And remember, canceling means anything that can create that one. So any common factor over itself, right? So let's look at number 1 here. Times 18y over 25x. So on this particular example, it's pretty basic, but we're going to break down our numbers to 5. Now, x to the third, you can write that out as x times x times x, so that you can understand how to cancel. And x squared and y squared as x, y, y. 18 is 2 times 3 times 3 over 5 times 5 times x. So now I'm going to see what can cancel. So 5 can cancel with a 5. 3 cancel with a 3. 3 cancel with a 3. So these 2's cannot cancel because you have to be able to be over itself to cancel, right? We should understand that. So 5 on this left side cancels with this 5 over here, because really it's just top and bottom, not left and right. So then we can multiply back together what we have, or we can just start canceling. So I'm just going to multiply what I have. So I have 4x cubed y over 5x cubed y squared. So x squared times x. And then the y squared just comes, and this is x cubed times y, and then 2 times 2. That's how I got the 4. So now we have a single rational expression that we should be able to simplify based on our chapter 5 material. 4 over 5 doesn't reduce. X cubed over x cubed, that cancels. Y over y squared, that leaves me with a y in the denominator. Nothing you've learned is irrelevant. Nothing you've learned can just be tossed out the window. So at some point, you're going to need previous knowledge that you've learned in the class moving forward. So once we get it down to this single rational expression, oh my goodness, this is chapter 5 material. I just have to simplify this. It's a division. X cubed over x cubed, 3 minus 3, x to the 0 power, or x to the 3 cancel each other out. Y over y squared, that's a 1 minus a 2 because it's exponents, right? We're trying to figure out how to reduce the variable components being divided. 1 minus a 2 is a negative 1, so y is left at the bottom. That's it. Okay. All right, the second one, 5x minus 15 over 10 times 3x over 2x minus 6. So what you should do is break down everybody that can factor. So 5x minus 15. So again, I recommend scratch work. So 5x minus 15 has a GCF. And then I could factor 2x minus 6, which would have a GCF. All right, so 5 times x minus 3 over 2 times 5 times 3x over 2 times x minus 3. So I break down what I can, and now I'm going to see what can cancel. X minus 3 cancels with x minus 3. 5 can cancel with 5. And that's it. So when I look across the top, everything canceled on this side, so it's just an imaginary 1. So I have 3x over 2 times 2 is 4. Nothing else can cancel. I'm finished. So remember, there's a times here. So you just multiply it back together whatever's left. Just like we did at the top up here. So it's just basic fractions. Break down all your components. Cancel out like factors. And then multiply back together what's left. And that's it. All right, let's look at number 3. 5y squared minus 15. All right, so remember we're multiplying. So we're going to break down everything. So 5y squared minus 15y. So I'm going to factor that as a GCF 5y. So y minus 3. And then 2y minus 6 has a GCF of 2. All right, so 5y, y minus 3, over 3y squared times, I'm going to break down my 15, that's 5 times 3. And then my 2y minus 6 is going to be 2y minus 3. So 2 times y minus 3. So now I'm going to cancel like factors. So y minus 3 cancels y minus 3. I have this 3 cancels with this 3. So I have 25y squared, because 5y times 5y. So 25y squared over, this is a 1, right? So 1 times 2y squared. So what happens here? Y squared cancels with y squared, so 25 over 2. And that would be the final answer, because we're not going to reduce that anymore. And that would be it. So we break down every part, and then we bring everything back together once we've canceled out common factors. Now, if you know how to cancel, and you can see it before you multiply, that's fine too. All right? All right, let's do some more. Okay, so we're looking at number 4. X squared plus 4x minus 21 over x squared times x squared minus 7x over x squared minus 49. So what we're doing here, you're factoring wherever it's possible to factor, and then you're canceling like factors. So I'm going to take, and again, my recommendation is to draw a little line so you know where your scratch work is, separate from where your problem is. So I'm going to have to factor all my little components over here. So x squared plus 4x minus 21. So this is where I'm going to go through my factoring process. You use the process you know how to do based on what you learned in chapter 6. If you look at my work and you don't know what I'm doing, you didn't learn nothing in chapter 6, because you're supposed to know how to factor before you get to this chapter. So again, this chapter is going to allow you the opportunity to go back and practice your factoring to help you get better, because you want to be able to do it faster so that you can get through these problems. So factors of 21, that'll give me a 4, 7, and 3. So x plus 7, x minus 3. Then I have x squared minus 7x that I have to factor. So there's a GCF present. So I'm going to factor out an x. And then that's it. Nothing else can factor. And then I have x squared minus 49, which I need to factor. That's the difference of two perfect squares. So x plus 7 and x minus 7. All right. So now I'm going to replace all of my my polynomials with my factored form. So x plus 7 times x minus 3 over x squared times x minus 7 over x minus 7 times x plus 7. So everything got replaced with its new factor form, right? You should be able to see that. X squared minus plus 4x minus 21 is x plus 7 times x minus 3. The x squared is just x squared, or you could write it as x times x. Let's do that on that one just because I want to show you something. Then x squared minus 7x is x times x minus 7. And then x squared minus 49 factors into x minus 7 and x plus 7. So now we want to see what can cancel, because we definitely don't want to multiply all this crap back together. So you just want to factor it so that you can see what will go away. That's what you want. So let's see what goes away. X minus 7 cancel with an x minus 7. X plus 7 cancels with an x plus 7. Remember, it's not about which fraction it's a part of. It matters whether it's a numerator and a denominator. That's how you can cancel. You can only cancel factors when they're one over the other. So if we were to write this as one common rational expression, which is the definition of multiplication, right? You can really write them as one. So the definition of multiplication, just to refresh your memory for fractions, is this: the top times the top, bottoms times the bottoms. So x plus 7 times x minus 3 times x minus 7 are all tops. The bottoms are x times x, x minus 7, and x plus 7. So these x plus 7s cancel because one's up and one's down. And when we look at it, we can also cancel an x with an x, right? Or you could have used and kept the x squared and just use your rule of subtraction. So when we bring this back together, we have x minus 3 over an x. And that's it. Final answer. All right. So if we hadn't have written it as x times x, let me show you. So let's say you just cancel. So you're left with x times x minus 3 over x squared. So all I did was bring everything back together. Don't actually multiply it. Just write it as one, like they're multiplying to each other. And now when I look at this x could cancel with an x squared because this x is its own factor. So if you cancel an x with an x squared, what does it do? It leaves you with an x at the bottom. Okay? And remember, the x over x cannot cancel because this is an x minus a 3, which is a factor. All right? And that's it. So we factored everybody that could factor, and then we canceled out like factors. And we brought back together whatever was left. And that's multiplying rational expressions. Okay? All right, so now we get into the division. Well, division is the same. So let's look at the rules for dividing. Dividing fraction says if you are dividing, it really means that you are multiplying by the reciprocal. Okay? So that is just the generic definition of dividing fractions or rational expressions. So when we look at number 5, we have x over x squared minus 25 divided by x squared over x plus 5. The very first thing you do when you see dividing of a fraction is to rewrite it by changing it to multiplication and flipping the second fraction. Because division by a fraction really means to multiply by its reciprocal. That's a basic fraction rule. That's a basic mathematical concept. So when we see the dividing, we are going to change it to multiplication and flip the second fraction. Then you're going to work your problem the same. You factor wherever possible and you cancel like factors. So here we go. X squared minus 25 can factor. And then that's it. So when I look at my problem, I'm going to replace this with its factored form. So this is what I'm looking at. So what cancels? Well, x plus 5 cancels with x plus 5. So I have x over x squared times x minus 5. Well, x and x squared can cancel. Because remember, x squared means what? X times x. So x cancels with an x. So we're left with 1 over x times x minus 5. And that's the final answer. Okay. So we just cancel what we can, and that's it. So we could also, before we cancel, we could have written it as 1 complete fraction, and then you can see what cancels. So you can choose the best way that you're comfortable with once you factor everything and put it back into the problem. Just make sure you're canceling and you can see everybody that cancels so you can get it correct. Okay? All right, number 6. All right, so x squared minus 36 over 6x divided by x plus 6. So remember, this is an imaginary 1 under here. So when I write this problem, division turns to multiplication and the second fraction flips. All right, so what do I need? I need to factor x squared minus 36. So x squared minus 36 is just the difference of two squares. So x minus 6, x plus 6 over 6x times 1 over x plus 6. All I did was rewrite. So what cancels? X plus 6 can cancel with an x plus 6. So we're left with x minus 6 over 6x. That's it. The problem is finished. So once you follow your rules by changing the division into a multiplication and flipping the second fraction, you're just going back to your same process. Factor where you can, and then cancel out like factors. And that's it. So pause it, and you should do 7, 8, and 9. And I'm going to do them too, and we'll see how you do. Okay? All right. So on number 7, so I rewrote it. I turned the division into a multiplication, and I flipped the second fraction from the original problem. I factored where I could, so the x squared plus 3x plus 2 factors into x plus 2 and x plus 1. So then I look to see what can cancel. X plus 2 can cancel with x plus 2, and x cancels with an x here. So I'm left with 1 over x plus 1, with an x left over, because this is x times x. So one of the x's goes away, and that's it. So that should have been your answer for number 7. 1 over x times x plus 1. All right, number 8. All right, so for number 8, first thing I did was I rewrote the problem. So division turned into multiplication. The second fraction got flipped upside down. I multiply by the reciprocal. So then I take wherever I can, I took every component, every part of each fraction, and I factored it. So x squared plus 18x plus 16, x squared minus 6x plus 9, 3x minus 9, and then 2x plus 8. So this is my recommendation. Again, if your work is not organized, you will get lost in these problems. You have got to separate the scratch work for your factoring from your actual problem. Do not try to factor your problem within your problem. You will get lost. It is too difficult to do that. You want to factor everything on the side. So every problem should like have a line like I'm doing it on here, where you have your scratch work where your factoring is done on one side, and then you go back to your problem where you substitute in your factors. So now I'm just going to write my factors back into the problem. And that way you make sure your factors are okay, and then you are substitute them in. So let's see what we can cancel. An x plus 4 cancels with an x plus 4. X minus 3 cancels with an x minus 3. So when we look at what's left, it's very important. So x plus 4 times 3. You have to make sure you write it in the correct mathematical form. So the 3 should always be written in front. We would never leave the 3 behind. So what I mean by that is we would never do this. Right? So it's written behind here if that's how you wrote it at first. But you have to make sure, you want to make sure you're putting it in the correct form. We distribute from the front. So this would be considered a coefficient. So it should be in front the parentheses. And then the denominator would be 2 times x minus 3. Nothing else can cancel out. That would be the end of the problem. Okay? So if you had it written backwards, like you had this, that's okay, but now you understand you must write it like that. Okay? Don't distribute, leave it factored, just write everything back together. All right, number 9. Okay, so here we have number 9. So I flipped first, right? So I turned my division into a multiplication. So the x squared minus x minus 12 became the numerator, and then x squared minus 6x plus 8 became the denominator. So I flipped my second fraction. Now I just have to see if everybody factors. So I factor wherever I can. So I'll pull everybody to the side, and I'll see if I can factor. And everybody factors. So the x squared plus 3x minus 10. Factors of 10 that give me a 3. So I factored that one. So x plus 5 times x minus 2 over x squared plus 8x plus 15. So that gave me x plus 5 times x plus 3. So it's important for us to understand that the factoring part I am going to do quickly. Why? Because we're in chapter 7 and factoring with chapter 6. If you don't know how I got these factors, you didn't learn nothing in chapter 6, or you didn't learn it enough to retain it. You need to go back and do it. I'm not about to show you all of that work. You're supposed to know how to factor at this point, right? So I figured I'd do that for y'all since y'all miss me yelling at y'all for not knowing nothing, huh? Just kidding. I'm sorry. I'm just entertaining myself. But you know who I am. So then we have x squared minus x minus 12. So I factor that, and I have x minus 4 times x plus 3. And then at the bottom, this is a parenthesis, I have x squared minus 6x plus 8, which factors into x minus 4 over x minus 2. All right, so I just had so much fun factoring all that. Now I'm going to see what cancels. So x plus 5 cancels with x plus 5. X minus 2 cancels with an x minus 2. X minus 4 cancels x minus 4. X plus 3 cancels x minus x plus 3. Everybody canceled out. What does that mean? It means 1. Because the top look just like the bottom. And if everybody is gone, what is always really there? A 1. A 1. Isn't that a beautiful, fun problem? I think so. I'm sure y'all like Ms. Wooden. You're losing your mind. But that's okay. So multiplying and dividing rational expressions. It is a very, very basic concept. It is very simple when you understand you are literally taking the exact same process you use for regular fractions, and it has evolved to algebraic rational expressions. So you have to know how to factor and break down those polynomials so that you can be able to see how to reduce it to lowest term, which is by canceling out the like factors, okay? So 7.1 and 7.2, very, very similar sections. Essentially, you're going to factor where you can and cancel out like factors so that you can reduce your problems to their lowest terms. And that's it. So that's 7.2, multiplying and dividing rational expressions.